So 6.2 gets into inverse functions. Again, remember, inverse is just backwards thinking. So one of the things we pick up on with inverse thinking is, especially if you're a mechanic, if you think about a mechanic and how he works, if he's working to take off something in the engine, he meticulously takes off things and places them in a specific order. And once he replaces the part, he kind of reverses his pathway back. So the first thing he takes off the second thing, takes off the third thing, takes off the fourth thing. And then once he's fixed this problem, the first thing that goes back on is actually the fourth thing. So fourth thing back on, third thing back on, second thing back on, first thing back on, and it should be back to its original form. So that's kind of where some of this math is going to take us, is going the other direction, thinking backwards, but we're going to be thinking backwards in terms of a function. We talked about inverse operations, adding and subtracting our inverse operations. We talked about multiplying and dividing being inverse operations. We talked about square and square root are inverse operations. So this is going to take this to the next level. So one of the first things we have to pick up on is this concept of a one-to-one function. So remember, for a function to exist, a relation will represent a function if the domain goes to a series of calculations and results in a range value. So let's see here. It should be like, and results in a range value. So remember, a function, input values go through some type of formula, and it results in an output value. We also call that input values domain, output values range. So a relation is kind of just, it represents only some of the solutions in a function. So a relation will represent a function if each domain value goes through a series of calculations and results in a range value. So in other words, as we mentioned before, for a function to exist, the x value cannot repeat, because if it does, that means it was assigned to more than one y value, and that can't happen. The x value has to be assigned to exactly one y value. Now, for a one-to-one function to be present, the function has to be able to go backwards. What that means is the range value will go through a series of calculations and result in a domain value. So in other words, the y values cannot repeat. So if a given relation, for it to be a one-to-one function, the x values nor the y values can repeat. So if I look at this function up here, notice how 4 went in, 9 came out, 5 went in, 9 came out, -7 went in, 14 came out, 1 went in, -17 came out. So notice that the x values kicked out one y value. But if you look at it from the other's perspective, 9 went in, kicked out a 4, 9 went in, kicked out a 5. A range value can't be assigned to two different x values, so that's going to crash as a one-to-one function. So this is going to be an example of no, not a one-to-one function, because the y values cannot be associated with two x values. So if you see a y value repeat, that means it's associated with two different x values, and that cannot be in a one-to-one function. So